A unit hydrograph is a direct run of hydrograph resulting from one unit of constant intensity, uniform rainfall, occurring over the entire watershed. How do we generate a unit hydrograph from hydrological data? Learn it here in hydrology. Given data of time in hours and precipitation in QMEX, we are to create a 1-hour unit hydrograph. The direct runoff will be determined by separating base flow through single line method, starting at T of 1 hour and ending at T of 6. The catchment area is 102 square kilometers. Let's draw a hydrograph and identify the points, starting with 168 QMEX for T1, followed by 257 at T2, then 420 QMEX at T3. This is the peak discharge of the graph. Then it goes down to 293 at T4 and still plunging down to 124 at T5 and ending with 83 at T6. Now let's separate the base flow using single line method. The start is at T1 and it ends at T6. Connect these 2 points where we have just created a triangle. The span has 5 hours and the vertical distance is 168 less 83, which is 85. From the table, T1 has a precipitation fully as base flow of 168. Now, the change of height or delta is then taken as 17 QMEX per hour. So at T2, we take 186, then subtract 17 to have 151. At T3, the base flow coordinate is 151 less 17, which is 134, followed by 134 minus 17, or 117 at T4. Then at T5, the base flow is taken as 117 minus 17, giving 100. The base flow column has been completed. Next is to solve for the direct runoff, where we only have to take the difference between the discharge or precipitation and the base flow. At T1, the precipitation of 168 was totally considered as base flow, leaving no direct runoff. At T2, 257 minus 151 leaves 106 QMEX for direct runoff. At T3, it is 420 less 134, which is 286 excess. Then 293 less 117, or 176 QMEX at T4. 124 minus 100, or 24 for T5. And again, no excess rainfall at T6. The column for DR was completed. In generating the unit hydrograph, we need the volume of direct runoff, and that is the area of the graph above the base flow. In the illustration, we are looking for 5 partial areas. A1 is a triangle with base of 106 QMEX and 1 hour height. Inject the conversion of 3,600 seconds for an hour to cancel out time units, thus having 190,800 cubic meters. The second area is a trapezoid, so take half of the height of 1 hour, then multiply the summation of the two sides, 106 and 286 QMEX, and again have the conversion, which eventually provides 705,600 cubic meters. A3 is another trapezoid, solved as half of 1 hour times 286 plus 176 cumex, with the conversion resulting to 831,600 cubic meters. The fourth area is yet another trapezoid, having half of 1 hour times 176 plus 24 cumex, then the conversion of 3,600 to have 360,000 cubic meters. Then A5 is a triangle, so use half of 1 hour times 24 cumex with the conversion. This gives 43,200 cubic meters. Take the summation of these areas and have the volume of direct runoff as 2,131,200 cubic meters. After taking the volume, have this converted into depth, and that is by dividing direct runoff volume by the catchment area, or 2,131,200 cubic meters upon 102 square kilometers, with a conversion of 1,000 meters per kilometer. The depth is then computed as 0.02089 meter, or take it as 2.089 centimeters. In order to create a 1 cm volume of unit hydrograph, the excess rainfall is then divided by the depth. So, 1 hour UH is 0.41, followed by 106 over the depth, or 50.741 cumex per centimeter at T2. Next is 286 divided by 2.089, or 136.908 cumex per centimeter at T3. UH at T4 is 176 upon 2.089, or 84.251 cumex per centimeter. Also 24 divided by 2.089, or 11.489 at T5. T6 is 0. We have generated the 1 hour unit hydrograph. Now it's your turn to solve the following problem, similar with the example. The data is with 2 hour time intervals, where the base flow separation will be through single line method from T2 until T12. The water basin has an area of 72 square kilometers. Solve for the 2 hour unit hydrograph, then determine the peak discharge, which should be 46.454 cumex per centimeter. Good luck!